Good afternoon and welcome to our webinar about WR steel, our wear steel that we produce in Ovako, and it's a brand that we have, and we will today discuss and show you a bit more about this and how we do it. My name is Patrik Ölund. I'm head of our R&D, Group R&D within Ovako. And together with my colleague, we will present this, and you can present yourself.
Of course. My name is Adam Hylén, and I'm head of business and product development within our business units, Smedjebacken and Boxholm.
Okay, let's have a look at what we are going to present today. We have content, of course. We will start a bit about presenting what Ovako is, what kind of metallurgies we have, and so on. And then we're going to dig into the fundamentals of wear, on what we see and how we have solved this, and try to understand and also simulate or mimic wear in real applications. And then we will have some about our WR steel offering. We will also have questions available, so please use your chat function and write there. And we have a moderator here, Anna, that will take care of those, and we can then answer them in the end of this session. If we don't have the time to answer all, we will of course gather them and we will send them out also per mail. And then we will wrap it up with some end remarks. But it's not just me and Adam that you see here that is involved in this. We have a lot of other persons in this team. We have Emil Svensson working on WR Steel in the marketing side. Myself, we have Camilla working in the Smedjebacken with WR Steel together with Sofia. And I'm Gunnar on the technical customer service side, and Adam, you already introduced yourself.
Yeah.
But I will leave now the floor only for you, Adam, to start this journey.
Thank you very much. So, the WR steel from Ovako, as most of you are familiar with, I think, is that within the Ovako group, we have three metallurgies. We have three steel mills. It's Hofors and Smedjebacken here in Sweden, and then we have Imatra in Finland. And when you are thinking of Hofors and Imatra, you're probably thinking about bearing steel and clean steel, hybrid steel, and all those things. And of course, from Imatra, we have this fantastic machinability, the M steel coming out from Imatra. But actually, we are also producing WR steel, wear resistant steel, both in Hofors here, where we are located today, sending live to you all from the research center, and also in Imatra. There's a high demanding products going out to, for instance, for mining, rock drilling, grinding media. Those type of products are coming out from Hofors and Imatra. But of course, when we are talking about WR steels, the big share is coming out from our metallurgy in Smedjebacken. We are closing into almost 100,000 tons of products coming out from the Smedjebacken Boxholm flow of wear resistant products, going into segments like agriculture and construction equipment and so forth. So we have three metallurgies where we are producing and melting the steel. So we have full control over that, and then we're taking these steels and we roll them, and going out with a lot of different shapes and forms that we can roll here within the Ovako group. Of course, as WR products coming out as round bars and flat bars, but also tubes, and one big segment within the WR products is the special profiles. You see them over here, the special profiles that's used as a lot of wear protection for buckets, for instance, but also we are producing profiles for tracks, for forestry machine and things like that. And we have almost 700 different special profiles. So there's a variety of profiles, but also our dimension, big broad dimension areas with the round bars and the flat bars is also a big part of the WR package. So what we are doing is that we are melting and we are rolling the steel, and almost everything that we are supplying out to you, the customer, is in the as rolled stage. And this is where it's starting to get really exciting, because what you, the customer, are doing with our WR steel is that you are taking our as rolled products and then you heat treat them into the desired mechanical properties that you need for your end products. And so this is always, when it comes to the WR products, it's a combination here that we need to do the right steel together with the heat treatment that you are doing. And that's a lot of different ways of heat treat the different steels from Ovako. And a lot of different combination. You can quench with water, oil, salt bath, and do a lot of different things. So and this is something that we would like to talk to you more about, and to understand this, and how can we get better wear resistant properties. And this is really where our research team is coming in from Ovako. And that is why I'm now gonna introduce Patrik again. He's coming in here to talk to you about those steps.
Yes, thank you, Adam. Yeah, we have these applications, and as Adam's already mentioned, these are the ones that we are looking and facing and talking to these customers. But what we can do is really improving certain components in these. And in order to understand really what is the demand of these components, we have to look at them. So we will take parts of these, looking into what kind of wear do we have in these different applications, and try to understand and classify it really into different mechanisms. Because we want to take these ones and we want to understand what type of wear do we have. And we have a lot of different ways of doing that. But I would say the most used that we started with was really to look at in our scanning electron microscope, of course. But you can really study the surface. You can look at the different types of components and look how has these been affected by this particular wear. You can see things that get embedded inside the steel because of mining, for instance. You can actually push the rocks into the steel, or you can get more homogeneous wear, or you can get small cracks or fragments. So we need to understand each and every type of wear mechanism, and we've done that. So we looked at those, and we gone one step further, I would say, try to classify that into different mechanisms. We have like plowing, wedge formation, cutting, and cracking that we also can experience. And then we think about how should we be able to translate these ones. So we understand the application, and we can do some kind of test method that is controllable within our facilities to be able to capture these. So we have a look at those, and we found that to be able to understand these basic things that we looked upon on the application we looked at, we need, of course, to know the strength. The strength is very, very sort of central. It really gives you how much it can cope with, and normally you have also certain requirements on the strength. Then we also add the abrasive resistance, and then you can say, but if you have the strength, why do you need the abrasive resistance? But we understand that this is not really the same always. There is a strong correlation, true is, but with heat treatment, with different structure, just what Adam told you, we see that we have a lot of potential in exploring, doing good things and interesting development work here together with our customers. And then of course, last but not least, in some applications especially, the toughness is really, really important. Especially if you have a lot of impact, then toughness becomes extremely important because you don't want to have fractures. So these are the ones that we would like to really target and to summarize in some way to be able to compare one steel and heat treatment to another. And what we do is of course the strength. It is pretty straightforward. You can do it by a tensile test, but you can also do it with hardness, which is pretty well corresponding or good correlation. And we chose to take the hardness as it is a bit more simple. And there's also another benefit. It is actually what we can do is we can take the same type of samples we can use in all of these different tests. It's a very similar like the shape or the size as a sharp EV impact sample. And then we use that and we can measure the hardness on it. We have also then possibility to measure the abrasive resistance, where we develop these Ovako WR drum we call, these abrasive tester that I will show a bit more about in the next slides. So these ones we have, and then finally the toughness, which we normally measure then with ordinary sharp EV impact. Those three. And we started the journey quite early looking at this abrasive wear, and we started understanding what type of tests should we make in order to capture. And I have some nice picture here or a film of an old drum. This is the first, actually one of the first tests we made, and we made it in sort of high-speed filming in order to see what kind of experience do our samples, or what kind of impact and what kind of abrasive media does our specimen experience during this. So this is sort of the prototype that we started off in the early days and really used in order to find the right conditions and finding a abrasive wear test method that we can use and that is reliable. It doesn't look like this today. It is really brand new, and we have constructed this and actually it's much controllable with programming. We can do a lot of we can measure the wear after certain times, and it is very much automized. And we put the samples here and we test them for a period of time, and then we measure the weight loss and we look at the samples as well. So it's quite exciting. So this is what we do, and then why we do this. Why is it so important to quantify the abrasive wear in this? Why did you buy a machine? Why didn't you use traditional ones like the pin on disc or whatever they are called? The fact is we found that these were not really sufficient to really for the requirements that that Adam had, or Adam's customer had, because we needed something that is a bit more aggressive, a bit more abusive to our steel, in order to really have the tough conditions, because these steels are actually used in very tough applications. And we know that depending on the microstructure, it's not just to measure the strength and the pin on disc, because if you have the same strength, it's not necessarily so that you have the same wear resistance. You can see on this graph here that it's actually the weight loss, how much weight that is lost from the specimen when we have run them in our test machine. And it's actually the same grade that we tested, the same time, the same drum, and with the same hardness, so the same strength. But actually we just changed how they were heat treated, and now it's what Adam said is important. The heat treatment is also very important, and it's something that we also need to work much more on and be able to give recommendations. And you see there is a pretty big difference, even though a lot of things are constant. So again, the actual wear resistance, it will actually depend on the grade, yes, but also on the heat treatment. So all of these three type of testing, we can then quite easily show as a property. Sometimes we call it the property area. The bigger area, the higher properties you have in all. Or you can just put it in a table and show them like individual values. And then we have actually the possibility to compare different materials and heat treatments with each other. And we have just one example here. We've actually tested a material in an application. So we got a piece of from the application. We made these samples and we ran all the tests and we plotted them there. And we can actually suggest an alternative solution that in this case was actually exceeding all the properties that the current solution had. And of course we can do this for any application, and we can try to meet the best, the most efficient, most cost-effective type of solution that we can. So we have actually now a test strategy or a test procedure to really screen the materials and really then be able to find new solutions. We can also really target and look at these different kind of parameters and see in your application, do we see more cracking or do we see more plowing? Is it toughness that is important, or is it the strength, or is it the abrasive resistance? So this is where we this is a really big strength, I think. It becomes much more visible. It becomes easier to discuss and talk about, and really to put targets on. So I'll leave it over now to Adam again, because now you will wrap up our offering.
Thank you very much, Patrik. Yes, so we are, as you can see now, we are really taking steps here to understand and the importance between the steel and the heat treatment, the different structures. And we have done, as you've seen, a really big job here, and we just want to tell you that all of these that we have talked about, we have tried to put in one place. It's on our website, so we have technical reports there. You can go into Ovako webpage, ovako.com, and there under the steel navigator you can find WR technical reports when we describe these different test methods that Patrik was talking about. You can also find the different WR steels that we have, or that you can look at. You can get material sheets, and I hope that it's come across to you, and how important we at Ovako see this, that it's not only about the steel, it's also how we heat treat together with you as the customer. And we have today developed this heat treatment guide. So here you can really also go into dig into and get more details about heat treatment of the steels. You can compare different steels, take the different WR steels that we have and compare and find even more information when it comes to heat treatment. And so if you search, you can find a lot of the different WR steel. If we look at the big groups that we're talking about, we have of course the microalloyed boron steel. That is a big part of the offering that we have. A huge into agriculture and construction equipment. They are really cost efficient when it comes to alloying, easy to shape. A lot of them is very easy to weld. That is important to have the possibility to weld these on a bucket, or and things like that. We have the low alloyed quench and tempering steel groups that is really tough. You can get very good and into the tough if we're talking about moving away a little bit from the sliding abrasive, going into more of the impact. And then you have the high carbon steels, of course, the group where you get really high hardness and can withstand sliding abrasive really much. So you can find a lot of things on our website, but of course we are also here. Talk to you, Ovako representative, and we would like to talk about WR steels much more directly with you. So just to sum up a little bit, we are really taking a step here to understanding the fundamentals of wear resistant steels. We know today that we really need to do this together with you, our customers, do the heat treatment, to be able to together find the best solutions for the wear resistant steels of tomorrow. So this is a combined work between you and us. So we're really looking forward to hearing from you and your questions and discuss this even further. So with that, we are waiting for Anna here to also come in.
Now it's time then to
see if we have anyone online
any questions.
if it's come in any questions.
Now let's now we are all here.
Yeah, I'm sorry to say, but the chat wasn't that intense.
It wasn't that intense.
Ah, okay.
No. They were
Did anyone listen at least? Or?
Yes.
Yeah,
yes.
There was, okay.
Yeah.
Good.
They did. And maybe it was so clear, everything, but from behind the scenes, I will say that I have two questions. I have one for Patrik.
Okay.
And the one first is, how can we get our material tested?
If you want to have the material tested by us, yeah, I think the best thing is to talk to the team that Adam has and explain what do you want to do. Is there something we can do together? Because we are prepared to work together. So if we have some project, we will make a small project out of it and discuss what we can do. And normally it's pretty straightforward. So if you would like to do that and have a good idea, a good case, talk to the WR Steel representatives or the sales representatives in Adams, and he will get you into this. I'm sure.
Yeah. I mean, we would love to. I mean, as we said, we need to do this together with you, the customers. So we are thrilled to get our hands on application and steels that been out there in the field and been exposed to look more into those and see how we can take this further. So,
yeah. And a question for you, Adam.
Yeah.
Where can you find more information then about the special profiles you mentioned earlier?
Oh, the special profiles. That's also just a similar question, a similar answer to this is to just talk to one of within the WR team that we presented earlier, or your sales representative, and we can get you all the information about the special profiles. They are rolled down in the site in Boxall, so the technical customer service there can help out on those. So.
Good, great.
Yeah, and I think it's quite interesting. We started this journey for a couple of years ago, and we are really finding it very interesting. I think we have really seen the big influence of heat treatment and what we can do with more advanced type of structures has given us sort of more and more information. And so we're starting to build a pretty good database now, I would say, in understanding different materials. We are right now looking very much in how much retained austenite content, for instance, influence on that and things like that. But also been testing different ospheritic type of steel and compared to bainite type of steel, compared to martensitic type of steel, and using this and building that knowledge. But also, I mean, we're also looking at what's next in the future. Perhaps we could expand this number of different tests to something else. I mean, it's also something that we of course would be very happy to discuss. Is corrosion an issue in some case? Is heat? Is what's important for you? Should we add something to this in order to capture these what you need to know when it comes to wear in a better way? So we are very open with that as well. So I think it is a development ongoing. We come pretty far. We have a good base to work from, and we will happy to continue to work with this. I think that's all. Wrapping up to this.
Yes. Well, thank you so much then, and we'll be back in January with the next webinar.
Yeah, we will have some new planned webinars. They will also come, and you will announce that in various ways. So that is. And if you have any questions, you still have time to put in the chat or just send some questions to us. I think that's it.
Yeah, thank you.
So we just say thank you for participating and wish you a good, Wednesday evening.
Exactly.
Okay.
Thank you so much.
Bye-bye.
See you.